So, hello everyone again. Welcome to the webinar about asynchronous resources with ActiveMQ. My name is Pavol Mederly and I work as a software developer at Evolveum. Okay, so today we will talk about first what are asynchronous resources, then when we should use them and when we should not, then how to use them. Then we will show a practical example, and of course there will be a time for a discussion. So what are the asynchronous resources? A little bit of theory first, maybe. What is the difference between synchronous and asynchronous communication? In synchronous communication, one of the parties sends a message to the other party and waits for the response. Only after the response is received, it continues with its work, like sending another message to someone or write something on display or basically whatever. Just send and wait. On the other hand, the asynchronous communication is characterized by party sending a message without waiting for a response. Either the communication is one way, so no response is expected, or it is two-way, but the response can arrive anytime later, like a second later, minutes, hours, days, or even months. So the principle is send and continue immediately without waiting. Now, let us see how these principles are visible in midPoint. First of all, it should be said that midPoint is primarily synchronous system. This is represented by processes that are well known to maybe all of us. Let's review them. When dealing with source systems, these are processes of reconciliation and leaf synchronization. When communicating with targets, here, then the standard provisioning used by midPoint is synchronous as well, and the target reconciliation is of course synchronous as well. Concerning the asynchronous world, midPoints provide an option of asynchronous updates from source systems, and when dealing with targets, the counterpart of standard provisioning is so-called asynchronous provisioning, and exactly this mechanism is the topic of today's webinar. We will show the things using a simple scenario, a fictitious university with a midpoint and a couple of typical source and target systems. Before exploring the world of asynchrony, let us recall how the standard processes in midPoint look like. The basic one is reconciliation. It is a synchronous process where midPoint asks a resource, for example, the student's database, a question like this. Well, please give me all the students. The resource responds, well, here you are, and sends the data. Of course, this schema is a little bit simplified, but this is the principle of communication during reconciliation. So we here see that midPoint is the one that initiates the communication, asks for data, waits for data, and processes them. The second typical example of synchronous communication is live synchronization. It looks like this. midPoint asks the source system, hello, what's new after 1614? We assume that 1614 is the time of the last modification known to midPoint. Database answers, well, I have 3 changed students, here you are, and the last one was modified at 1619. And typically this conversation continues like 5 minutes later. Well, what's new after 1619? Nothing. And another 5 minutes later, what's new after 1619? The database may answer, I have 1 changed student, he was modified and at 16:27 and so on and so on. This process repeats each and minutes or and seconds or and hours as needed and as defined by the administrator. On the other hand, the asynchronous updates from a resource are driven exclusively by the resource itself. So it is no longer midPoint who asks, give me the data, and so on. No, this time it is the source system that is active. As soon as it detects a change, for example, when a student services team member updates some student's data and clicks OK, the database or the application sends a message to midPoint informing it about the change. midPoint then processes the change. When the officer updates another student, let's say 3 minutes later, 16:17, another message is sent, and so on and so on. There may be time periods without any activity, but also periods with frequent traffic. Everything, again, everything is driven by the resource itself. midPoint is a passive information recipient here, meaning passive from the point of view of the communication. It receives messages and acts upon them. Let's have a look at the target side now. Here, the standard provisioning is synchronous. When midPoint learns about a change, like an update in student name or something like that, and decides that the change should be propagated to a target, it simply asks the resource to apply the update, like, please modify this account. The resource executes the update and tells midPoint, okay, done. And this answer, this confirmation is really important. Why? Why it is important? Because usually, maybe in 99% of all cases, the answer is positive, that, okay, done, no problem. But from the point of ensuring the consistency of the data, the most important is the fraction of cases when there is a problem. The resource may say, you asked me to modify an account, but I don't have such an account here. Or even more important, when midPoint wants to create an account, the resource may say, wait, there is already such an account here, so something wrong happens. The great benefit of existing synchronous implementation is that midPoint can react to such unexpected situations immediately. For example, by creating an account if it does not exist, or when discovering unexpected account by analyzing the situation, starting appropriate remediation process, or at least recording the current state so the administrators immediately know that something happened. On the other hand, the asynchronous updates on the targets are a bit simpler in the sense that midPoint sends requests that it needs to be executed, but does not expect any response, at least not in the current implementation. More on this later. As an example that we will use on this webinar, we can consider the dormitory application. midPoint may send it a request that modify this user, then later modify that one, after half an hour modify that one, and so on and so on. midPoint does not wait for the confirmation of the operation execution. It just records in its repository that the operation has been requested and continues with its work. It assumes that the operation will be eventually executed. And it is so. The resource will usually execute the operation immediately, but it is not obliged to do so. It can postpone the execution to more appropriate time, like when it is, of course, if it's down, it executes the operation after it goes into operational state, or if it's overloaded, it may postpone the execution to the times when the load is lower, and so on and so on. Now, we have learned about the principles. The key question is when to consider using asynchronous resources at source and at the target sites. I have prepared simple decision trees to explain the principles in I hope, clear way. So first, let us consider the source side. The key here is that we really need to ensure long-term consistency between sources and midpoint, and of course between midpoint and targets. And the primary mechanism for ensuring the consistency is, no surprise, it is the reconciliation. This means that the reconciliation should be always present if at all possible. So the simplest case here is when the resource is directly reachable, that means we can communicate with it directly, ask for data and so on. And if the update timing requirements are not too strict, so they can be met by reconciliation alone. For example, we may have a requirement to synchronize once a day, and the reconciliation may take, let's say, 20 minutes. And in this case, basically, there is nothing more. There is nothing more to do. We just set up the reconciliation and we are done. We can proceed to integrating another resource or whatever. Of course, more common is the case when the requirements are a bit stricter. Let us say we have to synchronize in minutes and the reconciliation takes longer, like maybe 2, 3, 4 hours or more. In this case, we have to apply another mechanism, and the next candidate is live synchronization. It is still quite simple, and it is largely sufficient in many situations. Okay. However, the timing requirements can be even stricter. We might be required to ensure updates in seconds, and if you remember, there is some overhead related to live synchronization. The midpoint should ask the resource may need to issue some lookup into database and so on and so on. So some overhead is there always, and this overhead might be prohibitive in these cases. Or maybe the live synchronization feature might not be available at all if the resource is a closed one. Then we can consider asynchronous updates that are, as we have already seen, driven by source system and can be very efficient. So this is this branch. On the other hand, if the source system is not directly reachable, that means that we cannot ask it for the data or for the changes, then our almost the last rescue are asynchronous updates. In this case, we have to use them with so-called attribute caching, meaning that midpoint maintains all the attribute values for all the resource objects he knows about. And of course, if even asynchronous updates are not possible, we have to be very creative and employ some unusual means like exchanging USB sticks or well, something like that. To conclude, asynchronous updates have their place in midpoint, either when the timing requirements are very strict, this here, or when there is no direct connection here. They have some costs. Well, first, it is still an experimental feature of midpoint. Also, the complexity is higher compared with the traditional mechanisms. And in the case of missing direct reachability, this is this branch, we have to accept the lack of reconciliation and the need of attribute caching. On the target side, the situation is currently even more simple. The deciding criterion is whether the resource is directly reachable or not. If it is, we use standard provisioning with occasional reconciliation. If it is not reachable, but if asynchronous provisioning is possible, we can use it with the limitations that midpoint cannot immediately react to exceptional situation that we have mentioned, like missing or unexpected account. And just like in the case of sources, asynchronous provisioning is an experimental feature with a higher complexity. Currently, it is always used with attribute caching and provides no possibility of reconciliation. If the asynchronous provisioning is not available, we have to resort to manual provisioning. That's again a standard feature of midPoint. I would like to add here that although the current implementation doesn't support informing midPoint about the success or failure of the operation, this may change in the future. If our customers would be interested, we could implement those confirmations, and that would open up a possibility of using asynchronous provisioning for resources that are reachable but slow to update, like those that take minutes to process a request. And this would enable the missing reconciliation and would eliminate the need of attribute caching. It just requires the implementation of feedback from the resource, asynchronous feedback from the resource to midPoint. After we said what is asynchronous communication, when to use it, let us describe how. From now on, we will not speak about asynchronous updates from the sources. We will concentrate only on the provisioning to targets, as this is new in midPoint 4.3, and it is the topic of today's webinar. The overall schema, slightly simplified, can be explained like this. midPoint has a computational engine called a projector that for each identity being processed computes a set of changes that have to be executed on specific targets, like create an account on target 1, modify account on target 2, or delete account on target 3, and so on and so on. These changes are then sent to so-called provisioning module, this one, that contacts the resources via specific connectors like LDAP connector, database table connector, CSV connector, and so on, or via custom connectors. Operations on asynchronous targets are executed also by a connector, but using a special built-in one that is called asynchronous provisioning connector. Its role is to translate the computed changes here into target-specific request messages and send those messages to given targets to be processed. Now, let us have a more technical look at the situation. The purple components and data structures are standard parts of midPoint, like the provisioning module, asynchronous connector, and the related documents shown as rectangles with folded corner, like the operation request here. The connector, as I said, the connector tries to convert the generic operation request into target-specific request message. Things specific to the target system are shown in blue color. How does it do the conversion? It needs a special configuration or even custom code to do that. This is defined by system engineer in the target resource definition here. We will show the details later on. After creation of the message has to be sent to the target. Usually a standard messaging infrastructure like ActiveMQ or RabbitMQ or any other similar broker is used. This messaging technology is probably less known, but it is quite mature and well established in various sectors. Its purpose is to enable asynchronous communication between applications, in this case between midPoint and the target system. The broker does this in the form of, I would say, mailboxes, very often represented by message queues. So midPoint sends the request into a defined queue on a specific broker, and the application will fetch it from the queue when appropriate. Yellow color here is used to denote these infrastructural components. The connection information like broker URL, credentials, and queue name must be provided in the target resource definition, as here. Because midPoint has to know what is on the resource or what it thinks is on the resource, it uses attribute caching to record the expected state of the target accounts in the repository. This is very similar to manual resources, by the way. This is denoted here. So this is the schema. This is how it works, how it's configured. Now let's have a look at the practical demonstration. We are going to show the asynchronous provisioning to a fictitious dormitory application via ActiveMQ broker. So we have a midpoint instance here. Then the source database of students represented for our purposes by a CSV file is here. And we have a simulation of an application for dormitory management. It is a very simple Java program here. And this box is the broker on which there's one queue called dormitory requests queue. midPoint sends messages here that tell the application to create, update, or delete user records in itself. And the messages will be in a simple text format like this. Let's pretend the dormitory application is a legacy one that basically doesn't know about XML or JSON or such modern data formats. Here are the key parts of the resource definition. This is the definition of the target resource. Yes, so this tells midPoint how to communicate with the dormitory application asynchronously. First of all, as for each other resource, we have to specify the connector type. All asynchronous target resources use this connector, async provisioning connector. The connector assumes, at least in the current implementation, that the attributes are cached. So we have to add so-called read capability with the flag caching only set to true. That's the first basic thing we have to do. Second, we specify where the messages should be sent to. For this, the targets configuration item of the connector is used. In the future, we in midPoint plan to support various types of target like JMS, REST, or others, but in 4.3, only JMS 2.1 targets are supported. JMS is an acronym for Java Message Service that is a standard API to communicate with messaging infrastructure in Java. Each broker like ActiveMQ, RabbitMQ, and so on has something like a driver. It's technically a Java library, an implementation of JMS API that allows communicating with the broker. The target address in JMS generally then consists of the, and in generally as well as here, consists of the name of so-called connection factory. Connection factory is a data object that points to a specific broker, typically using a URL like this, localhost 61616. This is name. This is connection factory named localhost connection factory that is referred to from this configuration. Then here are credentials and the name of the specific queue. Because of ActiveMQ specifics, we use the following properties file wrapped into a jar file and put on midPoint class path. These are some technical details behind this, but normally or as designed, JMS is designed to fetch this configuration from JNDI, Java Naming and Directory Interface server. But because those servers are not usual nowadays, they can be, I would say, simulated in various ways, and one of those ways is using plain properties file. Okay, so after we defined that, yes, we have an asynchronous connector that was 0.1 with attribute caching, and we said where the messages should go to, it is very important to define how these messages should look like. This information has two parts. First, we specify the logical or abstract format by providing the schema. Why we have to do so at all? Normally in midpoint, we don't do this. A standard resource obtains the schema automatically. If you have an LDAP, then during an initialization, the LDAP connector fetches the schema from the server. When you have CSV, again, during the initialization, the connector reads the first line of the CSV file and knows the data structure. If you have database table, it is the same, and so on and so on and so on. But now we have no connection to the target. So the only option is to define the schema manually. So here it is. We have an account with login, given name, family name, email, faculty name. In the real scenario, there would be many more items, but this is for our sample. This is the first part of data structure definition. The second part is then saying how operations upon this logical schema should be represented in those physical messages that will be sent to the resource. On this slide, to keep it simple, I have chosen to show predefined transformation that is called simplified JSON. And this is how the messages in the simplified JSON transformation look like. These are examples of add, modify, and delete operation. First, there is an operation kind, add, modify, delete. Then there is object class, because a resource typically supports various object classes. In our sample, we have only one, that's account object class. Then for add operation, we provide attributes, values of attributes. In modify operation, the simplified JSON format provides identifier or identifiers and a set of changes, for example, replacing Bob's name by uppercase Bob. And in the delete case, it is the most simple because it carries only the identifiers of the account that should be deleted. In the documentation on docs.evolveum.com site, there are details about all this configuration stuff, about the predefined transformations, and basically about everything that you need to configure such resources. If you remember, I have said that our resource is quite simplistic, and it cannot parse JSON. And well, this was just to show you an example from real life, so to say. So our resource expects plain text messages of two kinds: add /update and delete. So when adding an account, there should be add or on the first line should be add or update keyword. Then on the second line should be the login, that's primary identifier of an account that should be added. And in the application specific form, so some cryptic prefixes, there should be the attributes: given name, family name, mail, and faculty. The account modification expects the same format of message, this time carrying updated values of the attributes. And the deletion is again the simplest one, just the keyword delete followed by login to be deleted on the second line. And in order to produce such messages, any scripting language, clearly we see that some custom scripting or custom code is needed to produce such messages. So midpoint has support for a set of scripting languages like Groovy and so on. Though for messages like this, the Apache Velocity, a templating language that is also supported by midpoint, can be used with a great advantage. Well, we have used Velocity in, for example, in sending notifications, text notifications to users for many years, and now we can use it also when creating messages in these asynchronous scenarios. So here is an example this may look quite scary, but do not be afraid. The first set directive is a velocity directive, and it sets the request variable to this expression. Request formatter is a very useful helper object, again documented in the docs, that that does the heavy work. It knows or understands the internal midpoint structures describing the abstract operations, and can transfer it into simpler data structures suitable for further conversion to JSON or plain text. So we configure this request formatter by setting some properties using Java method calls, and here by calling create request method, we create the simplified representation of the original operation. Normally we would serialize this request into JSON, but now we instead just take the values of the attributes and proceed into construction of the message. In the case that the operation is of delete kind, we simply put the delete keyword and the value of the login attribute. Else, meaning it is either addition or modification, we put add or update keyword, then login, and then the values of the attributes to be created, or attributes or the modified values of the attributes in application specific form, just as required. Okay, so we have this, and now let us see if it works. So I have prepared this in the form of live demonstration, and it is prepared in such a format that you can try that yourself. So let me show you the steps. I will go quickly because of time limitations, but you can try this yourself later. So I use Windows, and I do have some temporary directories. So first, let me create the broker here. So creating a broker directory, and now let's create the broker instance. I have already installed ActiveMQ on my computer, so now I'm creating a broker instance. It is like if you have an Oracle, for example, database management system installed, then you create a database instance to put your data into. So this is, now I have to define my queues. Well, actually, it is sufficient to create this dormitory requests queue. It is done by editing etc/broker XML, and besides some system queues, let's put our queue here. Now we will start the broker. Okay, it will run. Now I have prepared everything in this GitHub repository. So let us clone it here. Not very big, and build. Because remember, there's a Java application there, and run the application. Okay, Java is running here. The console is here. Let's go back here. So now we are going to install midPoint. So again, tmp midpoint distribution is here. So unzip. Okay. As I said, we have to provide the JNDI configuration to the class path. So the Maven build, the configuration is part of the project. Maven build prepared jndi.jar file, so I'm copying it into lib directory in midpoint home. And now let's start the midpoint. Okay, this we have. Now let us open the project. And after some initialization, the project is here. We have, it has two parts. One is the Java application, and the other part is the midpoint configuration. We are going to upload it into our midpoint. We have to enable midpoint plugin here. So let's do that. Again, it is installed. We just enable it for this project. Okay. Done. And now we can upload orgs, resources. Well, I can delete some testing and temporary resources. So we can upload orgs and resources and roles. Here. It should work. Okay. Let me test the resources. Okay.
¿Viste que tengo 2 y 20 la topografía?
And
2 y 20.
we have the CSV file here. And let me import the students from the CSV file. So I import the import task into midpoint. Now let us see if it's okay and if it's there, if the students are there. So let us log in to midpoint and see the users are here. Okay, very well. So let us open Bob Anderson. Remember to show our in our dormitory application. As you have seen, no one has accommodation. This is the structure of the CSV file: login, given name, family, email, the code of the faculty, and the flag whether the user should have accommodation or not. No one has accommodation, and really no one is registered now in our dormitory application. So let us open Bob and give him the accommodation, add, save, and we see immediately the message was sent into the queue and it was fetched by our application, and Bob is registered in the dormitory application. If we, for example, change his name and family name and save, again the message is sent and we see the name is updated in the application. Let's get back. And now let's try something more dynamic. We can open the organization here and not, I'm sorry. Let's add members. So let's give everyone the accommodation, and we see here are the messages and here are the users. So again, we can do the reverse, select everyone and unlink or unassign. We see messages and the students are gone. If we would like to see, well, if we would like to see the full process, we can do the same basically in the CSV, but I think I'm sorry, I forgot to upload the live sync task. Okay, so this is the task, and now we can do that. Provide accommodation to 3 students, and after saving, we see that there are 3 change messages, and then the 3 students get their accommodation. Okay, the time is almost over. The time that I would like to talk, maybe a little bit more than I wanted. So let us continue here. This is just the summary. Yes, this is just the summary. First, asynchronous resources are supported, although experimentally. As we said, main reasons to use them: missing direct access, or the need to really immediate updates from a source, but this is in the future when the provisioning target is too slow, then after confirmation would be implemented in midpoint, confirmations would be implemented in midpoint, then we could also use provisioning to such reachable but slow targets. And the main things to consider when thinking about using asynchrony: please, no direct access means no guarantees of long-term consistency. So please do not throw away direct access. Use direct access if at all possible. Also, when provisioning asynchronously, remember, currently we lose the possibility of direct feedback. Yes, so this means limited or slower adaptation to the real state on the target resource. And of course, asynchronous means now higher complexity, and the current support is present but experimental. Nevertheless, the features are here. Please feel free to use them, experiment with them, and let us know about your experiences, your suggestions, your objections, anything. Thank you very much. So this leads us to the last part of this webinar, the discussion. You are welcome to ask questions or provide your comments either by voice or by using the chat as appropriate.
Oh, hi, this is Mike from Exclamation Labs. I'm wondering about the async provisioning connector, and maybe if there's an example of that in use, like an API that we could look at.
Excuse me, I didn't understood quite well. You are interested in async provisioning connector and?
Yeah, the async provisioning connector API.
Yeah. Aha. The connector as okay, I can show you, but it is quite deep technical information, because the API is well, it is hey, what's wrong with you? The API is basically an internal API of a built-in connector in midpoint. So the API is like initialize yourself, configure yourself, connect, disconnect. Yes, nothing I would say of interest, but maybe what is important? Well, okay. The key methods are add object, modify object, and delete object. Yes, this is the internal API between midpoint and the connector. Yes, so but normally you as an engineer do not come across this API. Your communication with the connector is through the configuration. Yes, so you do things like this. You configure it using the targets configuration and the script transform, message transformation configuration, and so on. This is how you work with the connector. Is it okay, this kind of answer?
Yeah, and a kind of a follow-up question then. So I presume that, like, just looking from a connector standpoint, then the connector would look the same whether it's asynchronous or synchronous.
Mm-hmm.
As far as like having
yes.
the query and add and update and delete and the test. Okay.
Yes. The interface from the midpoint side is the same. It is the connector instance. But of course, if you have a look, then for example, fetch changes. This is live synchronization or search. You see, these methods are just not implemented because they cannot be implemented. You cannot ask asynchronous target that what are users on your side. You cannot, because it has no way how to tell. In the future, it is possible to couple this connector with if you are familiar with semi-manual resources, then this may be understandable to you. You can couple, for example, if there is some other channel to access the asynchronous resource, you can use it in the form of additional connector. So for example, in this way, here is a CSV connector that you can use to read the state of the resource, but it is a separate channel. The primary channel for provisioning is the asynchronous channel, and the channel for looking at the state of the resource is the additional. Okay. Yes, maybe if you have another questions.
Yeah, thank you.
Now I'm no longer sure you understood what I have said, because was it clear or or was not? Because no questions could mean everything was pretty clear, or it was completely messy. So okay, anyway, so thank you all. If there are no more questions, so thank you all. If in the future any questions would occur, please contact us using any suitable channels, be it mailing list or here sales at evolveum.com. Anyone, we are really interested in your experiences with those asynchronous technologies. They are quite unusual and maybe not the mainstream, but they have their place, and we are really we really look forward to hearing from you. So thank you very much. Oh, excuse me. I see some questions in the chat. Okay. Thank you, Andrew and Ethan. Okay, no questions. So goodbye.